Hello, and thank you for tuning in. I'm Mike Kachurik with Bevolution Services. Today, we are going to learn about what it takes to pour that perfect fountain drink. We're going to review the post-mix system and all the ancillary parts behind the unit that makes that perfect pour. We're going to review the post-mix system. We're going to go over the flow paths. So the first one we're going to start with is the water flow path. 80% of our drink, our finished drink, is water. So it plays an important role in our finished beverage. So we require a 1/2 inch water line that's ambient or room temperature, the cold line if you will. And the shutoff should be supplied by the customer or the account. That shutoff can be a ball valve shutoff like in the diagram here, or a gate valve shutoff. Either or is acceptable, just need that 1/2 inch line. That's where we're going to hook up our beverage tubing. Okay. First thing we're going to come to is the pre-filter. Here we go. Pre-filter is going to catch any large debris in our water line. Okay, after pre-filter, we have the optional water booster. The water booster should be there to supply constant water pressure to our system. So if we have multiple fountain units pulling from that same water line, we may experience a pressure drop. That booster is going to increase that pressure and hold it up there anywhere between 80 to 100 psi of pressure. Now, a water booster is not meant to fix low incoming water pressure. We still require the 40 psi minimum coming in. A way to check our water pressure coming from the wall. We want 100 gallons per hour. Now, it doesn't take an hour to find out where we sit, or stand, or sit. We can use a 5-gallon bucket. We should achieve 1 gallon in 36 seconds or less, or the whole 5 gallons in 3 minutes or less. So right away, we'll know if we have 100 gallons minimum. Okay, after our booster, we go to the fine filters. The fine filters are taste and odor filters. It'll take out any chemicals that the city may put in the water, any off taste. The fine filters will capture that. Now, if we plumb it this way, that water booster is always before your fine filters. We want to push the water through the filters. We don't want to suck everything out of the filter. Okay, so this is their standard lineup here. The pre-filter can be before because it's catching any large particles. Okay. All right, this is going to boost it up 80 to 100 psi of pressure, pushes it through the fine filters, and then goes into our fountain dispenser. More like it will go into here behind the splash panel, but that plain water is going to feed our non-carbonated drinks, lemonade and so forth, and maybe a plain water valve. Okay. All right, we're going to tee off. There we go, get my clicker to work here. We're going to tee off after our filters, basically, and go to a regulator or pressure reducer. The purpose of that regulator is to, again, reduce our pressure. We don't want 105. Remember, this is going 80 to 100 psi. I don't want 100 psi of water going into my carbonator because I'm going to introduce CO2 in there around 100 as well, and they will not mix properly. The CO2 has to be 20% higher than your water to get it to bond. So we're reducing our water pressure here 50 to 55 psi right in there. Okay, so it's coming in 80 to 100 off that booster, regulating down to 50 or 55. It then goes into our carbonator, and that's where it's going to make our soda water, and that soda water will come out to our dispenser, be plumbed behind the splash panel, and that's going to feed all of our carbonated drinks. The next flow path we're going to go to is our CO2. CO2 is very important in our fountain beverages. That gives us the fizziness. But CO2 is doing a couple things here. It's making our carbonation, and it's powering our bag-in-a-box pump or syrup pump. So in this example, we have a 20-pound high-pressure tank here, probably the most common in local places, and we have a high-pressure regulator mounted to that tank. Now that tank is under pressure, extreme pressure. So it's crucial, I like that word crucial, but we need to secure this tank with a chain about 1/3 of the way down. We want to secure that to the wall or sturdy structure or your bib rack. We just don't want to knock it over. And the weakest point on that is the valve top here. And if that fell on the ground and busted off, that thing could launch like a rocket. So crucial to chain that up. Okay. Our high pressure regulator, what it's doing, it's going to lower our pressure. Basically, in this tank could be up to 1,500 psi of pressure or more. The high pressure regulator is going to reduce it to a usable amount. And in this operation here, this is an ambient room temperature carbonator. So we want to set that CO2 at 105 psi coming out of that high pressure regulator. Now it goes through, if you have a secondary regulator, you can tap right through that. It'll just send that 105 psi straight through, and it goes to our carbonator. And inside that carbonator, we're going to mix the water and the CO2 to make our soda water. Now on the secondary regulator, this is in place for our syrup pumps, or bag-in-the-box pumps, or bag-in-box pumps. And it's going to drive our pumps, going to operate it. Okay, so we're going to set this at 65 psi in this legacy fountain system we have today. And ultimately that pumps our syrup. Okay. You may see larger accounts go through a lot more CO2. And you may see the bulk CO2 tank here. Now that bulk tank can hold a lot more CO2. It's low pressure. It's not high like the one in the 20-pound tank. But that low pressure, it's about 400 psi in there, but a lot of volume of CO2. But we have a regulator that's built on top of the bulk tank, and we regulate that down to around 110, 120 psi. It will feed a set of regulators here doing the same things as what we saw before, but the primary and secondary are mounted together here. So your red high pressure is going to feed your carbonator, and then our low pressure is going to feed our syrup pump. So just remember 105 psi for carbonator and 65 for our feeding our pumps, powering our pumps. Okay, that's your CO2 flow path. The next one is our electrical flow path. Pretty simple here. Electrical flow path. We just need to make sure the cord is in reach of the outlet. We don't want to use extension cords. That's a fire hazard. So our water booster within 3 to 6 feet, we want an outlet, and also the carbonator. Now both of these, they don't pull that many amps, so they can be in the same outlet if you had both in the back room. Your fountain unit, manufacturer requires a dedicated outlet, 20 amp, 120 volt dedicated outlet for that dispenser. And again, no extension cords, just make sure the outlet's in reach of that power cord for your fountain unit. And by the way, shout out to Lancer here. Great company, great machines. I'm a big fan, so shout out to them. Okay. All right, let's talk about product. So the product flow path here, we have the bag-in-box. The bag-in-a-box product comes in 3 different sizes. You can have a 1 gallon bag of syrup. You can have a 2.5 gallon or a 5 gallon bag. Just depends on how much volume you go through. In this example, this is just a 2.5 gallon box here. And then you're going to need a syrup pump pretty much for any bag you hook up. So if you got, well, in this fountain unit here, we got 6 flavors. So you're going to have 6 bag-in-a-boxes and 6 pumps to push that product. Okay. So that product is vacuumed out of that bag into the pump. It's then pushed over to our fountain unit. Okay. Now with product, it's key how you store that product. We don't want it in a hot environment or a cool environment. So we don't want to store them in walk-in coolers, because what happens, that syrup will thicken up if it's in a cooler, or if it's exposed to heat. It's stored by maybe a fryer or an oven or a heat source. What will happen is those ingredients inside will break down much faster. So it will expire before that expiration date, technically. Now remember, in this example, the pumps are powered by, point the right way, by that secondary regulator. That's what's powering our pump. Okay. Let's move over to our drain. Our drain is very important. So we need to have an insulated drain coming off our fountain unit, because anything we're pouring down the drain of the fountain unit is cold, and so what will happen is it will condensate. So it'll look like a water leak. It'll be sweating on these hoses. So we have to make sure this is insulated. We also recommend a floor sink, which is right here in the middle here. Recommended. And then also with building code, you have to make sure you have an air gap, like a 3-inch air gap between the drain, the floor drain, and our fountain unit drain. And the reason being is we don't want any of those sewer gases backing up in our system. Or if this hose was down into the drain and the drain is plugged, you may have some of that wastewater pushing back up into our fountain unit into ice bins or drip trays, so that it wouldn't be sanitary. So a lot of health codes or building code, they want you to come up with an air gap bracket like so the drain's not in the floor, it's above the floor drain, about 3 inches. Okay, so that's a quick overview of our post-mix fountain system flow paths.